Hi, year 12s, this is Mr. Lim again. This is the last video on amino acids, physical properties, and then almost there to the end of organic chemistry. All right, so we're going to be learning about the physical properties of amino acids, their melting points, boiling points, their solubility, and something different, their brittleness. So amino acids exhibit ionic bonding due to their Zwitter-ion nature. Okay, so Zwitter-ion, remember, it's one particle with a positive and a negative end on the same particle. All right. The two charged end of the amino acids will act like ions with physical properties that relate to the sum of intermolecular forces, but not other things like electrical conductivity. So remember, electrical conductivity, you require a mobile charge particle, right? So technically there's a charge, but because they're a positive and a negative, you're going to cancel each other out, and so therefore it's a neutral particle overall, even though it has positive and negative ends. All right. So let's just show the ionic bonding between a few amino acids. Okay, so amino acids can have ionic bonding, where you've got the negative end there and the positive end there. Okay, and so therefore you're going to have ionic bonding between that amino acid there and the next amino acid and its positive end there. Okay, now this is different to when we deal with proteins later on, and so you'll learn about that later on, where a covalent bond is built between the two things. Okay, this is an ionic bond. Okay, and it occurs in certain situations where they're not put together by proteins and stuff like that. So this is where you have amino acids just in solution, and then you evaporate them and they crystallize, they form ionic bonding, but they do not have but it's different to when a covalent bond is built between the two amino acids, which we'll deal with when we get into proteins later on. All right, so because they have ionic bonding, effectively they have a very high melting boiling point. All right, so remember, it's due to the sum of the intermolecular forces, and the intermolecular forces here in this case are ionic bonds, which makes them very high. Okay, so ionic bonding, which means it's strong electrostatic attraction between the two particles, which means that amino acids, for their size, have ridiculously high melting boiling points. Okay, so anywhere between 180 and 300 degrees for a melting point. Okay, just to melt them. And then generally they will decompose if you heat them up even further to try and boil them. So they're just going to break down because they're not really built for that kind of heat. All right, so they have a very, very high melting boiling point comparable to weaker ionic substances. All right. They are soluble in water, okay, because remember, solubility is the ability to form bonds of similar or greater strength between solvent and solute. And when you have an amino acid, you're going to form ion dipoles or ligands with water. Okay, so here's your negative end, right? You're going to form a ligand with a H2O molecule. Which side is that going to be? The it's the negative end, so therefore it's going to be the positive end of your water molecule, and then this one's going to be to the negative end of that one there. Okay, and you're going to form an ion dipole ligand, which is a very strong bond, and therefore it releases lots of energy, and so therefore it will release enough energy to break the bonds between amino acids themselves and the water particles themselves. All right, so the ligands will form with the two ends of the amino acid, the amine and the carboxylic acid, as well as anything in the R group that happens to be charged as well. All right, but that ligand formation is important to remember. Okay, the larger the amino acid is, the lower the greater effect of the hydrocarbon end. Okay, so you do have certain amino acids, especially for ones with the benzene rings in them, which will have a lower solubility in water. Remember, it's not going to have no solubility, but it's going to have a lower solubility simply because the hydrocarbon end of it has a greater effect on the ability to form ligands, right? Also, the idea that we're dealing with the alpha amino acids that are that are present in the body, and so therefore those 20 or so are fairly well defined and they are all soluble. You can deal with other amino acids which are much larger, but then they're not really the ones that we're going to be studying with. So generally we just say that amino acids are soluble in water because they form the ion dipoles, which has sufficient energy to break the bonds between blah 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 blah, so on and so forth. Okay, so amino acids are brittle due to their Zwitter ion nature in solid form. Okay, so therefore it'll create an effective ionic lattice in solid form. Okay, so if you move these ones half a step across, your like charges are going to align, and then you're going to have repulsion here, and that's not going to be good for the structure, and so therefore amino acids are actually brittle in their nature. Okay, and so that's something else that you can describe about when you talk about amino acids. All right, so that's all for amino acids. We're going to be moving on to identifying the last of the organics, or all of the organics together, and then we're done.